a warm-up problem for you guys. It's in 11.6.
We'll see how this first test goes.
I will have the review ready for you after the end of class tomorrow. I will put it up on Canvas. It'll be a review exam, like what you can expect to see on the exam. And then on Thursday, we will go over it. So you'll have like one day to try to see how well you can do on the exam on your own. And then our Starbucks, I imagine this is what's going to happen during Starbucks, is that's what everybody's going to want to talk about, which is fine.
So we're through. Did anybody actually go? No. Nice. Okay.
There was a turnout.
That's good. You can know and that vector, and then maybe find some points on that new line, and then set like whatever like you want the, and then just set each plane like x, just observe like the XY plane, that z equal to 0, z equal to, just which one it crosses, or it can go big. That's one good like that. Just normal use space for the job, right? Yeah. I didn't look it over. So it's basically, yeah. We use this one. Yeah, wait. Oh, that's. Yeah, this looks like half like you. Where's that? Oh, who's it? Yes. Yeah, you want to look for the ones that are like a box. All of this shit like just proof of that. Do much stuff there. I'll pop out the actual thing in the bottom.
That's a little picture of what's going on as a little reminder from our video. Assuming you've watched it. Only half the classes watched the first video, and most students haven't watched even the second video. 12 views for 11.6B.
For this section or the
This
first
section.
section? Oh, this section.
11.6A has 22 views. 11.6B has 12 views.
Good
Which
thing you're
means you
not
guys aren't watching the videos before class like being asked. A good chunk of you guys aren't. That makes this shit really, you're like defeating the point of this class if you like the model is set up to do it this way. Please watch them. All right, so what can we do here? What is this picture telling us?
Pretty much what the question said,
What is the question saying?
that we're trying to find a normal vector to that plane that lies on that point, or at least contains the point.
Right, so I drew a plane containing that point and a normal vector to it. What can we use from that picture to come up with it?
Maybe like some triggers.
I mean, you could use some trick, but what else is there to do?
What trig can you use?
Oh wait, no, it's like kind of like it doesn't matter. Pretty much.
Okay.
You like just create that like body and like find the length of that P not to P. But no, you don't really have the height of that.
Yeah,
No,
that'll just
well-
give us information about the triangle. We want to talk about the plane.
Right.
Tangent,
True.
because tangent gets you the opposite.
Yeah, but that's not
your direct angle.
But again,
Right.
tangent is we're not looking at we don't want the triangle. We want the plane that the P not P is in. So what relationship do these two vectors have?
Orthogonal.
They're orthogonal. How can we show that two vectors are orthogonal?
take the cross product.
Dot
No,
product.
cross product finds a third orthogonal vector. If we
Oh,
just want to show two vectors are orthogonal, dot product should do it. So P not P dotted with N should equal 0. This is the equation for the plane. We just need to fill it in. We have N. N is 3, 2, 4. What is P not P?
X minus 1, comma, y plus 1, and then comma, z.
Correct. So we dot them. We've got 3 times x minus 1 plus 2 times y plus 1 plus 4z equals 0. And we can clean this up. We don't need parentheses. Gather like terms.
It's 2y plus 2.
You're right. Yeah, I won't, yeah, shit. Where was I? 4z. This is the standard form that we use. AX plus BY plus CZ plus D equals 0. That's how we describe the equation of a plane. And the reason why is we didn't say where P is. So it could have been over here, it could have been over here, it could have been over here. It could have been way over here. As long as it's in that plane, that vector N and P naught P, no matter where they are still orthogonal. And the P naught fixes which plane. There are a lot of planes that do that. I could have a plane that is exactly 1 unit higher up with a different P naught, and the plane is going to have a different result. So picking P naught in the plane narrows it down. And that's how we do a plane.
Oh, so we're not trying to find like if it's the XY plane or if it's the YZ plane or.
No. In fact, usually those are not one of the planes. The only way you're going to get one of those planes is if one of the components is 0.
Right.
In the vector. The normal vector. Is that right? Yeah. One of them is not changing value. All right. Any questions on that? Okay,
That was it.
let's do this one.
That's also good here.
Maybe we can discuss out a game plan of what we should do before you guys start doing it. What would be something we could do to find this value? To find this equation? What do we need?
Get to the.
You are.
We need to, or do we?
I'm hearing people saying you need 2 vectors.
We need 2 vectors for what? I agree, but why? Yeah, if we find 2 vectors, we can do the cross product. And what does the cross product give us?
The or.
A vector normal to the plane.
Yes, that will produce the normal vector.
Oh,
Once we have the normal vector, what do we need to do then?
Dot product.
Then dot product. With N and P not P. All right, go for it. Let's see what you guys come up with. Why don't we go? So we're all working on the same thing and someone else doesn't go. I use a different base one. Why don't we do PQ and PR? I see something in chat. James looks bored. See, I think I'm not making this hard enough if James is bored. I think, James, I need to enlarge this picture here. Pin this video, pin this picture.
Gosh.
Yep, it is James. I had to enlarge my picture. Why are you looking bored, James? Is this too easy? Sorry, James. I don't know why I'm picking on you, James.
You should.
Some people are just too easy to pick on, and they're just too much fun.
Yeah, that's something else. That's cool.
Well, I'm going to work behind you guys. You can glance up and make sure you got the same PQ and PR I do.
Yeah, for not even the big. QR. That's not.
Did you guys get those vectors?
Yes.
Yeah.
Like, for the P, we can choose the general, like X, Y, Z, right? No matter which one of these. Right?
Mr. Jones, can you explain how the matrix works a little bit?
The cross product?
Yeah, the cross product. Sorry.
Yeah. Okay. So you go through the columns one at a time, and it kind of helps to cover it up. Whatever the submatrix is, that's what I'm doing here. I'm making a little submatrix right here. So this one is -4, -1, 2, 1. I do the same thing when I do J. I'm doing 2, 1, 2, 1. And when I do K, I'm doing 2, 1, -4, -1.
All right. Thank you.
Write this down.
Yeah, I know. On the other side. Yeah. But it's still technically right. I think you can know way of doing it too.
This one.
Did you guys get that for your normal vector?
Yeah.
It looks right.
Awesome. Eli got it.
I just double checked it for you.
So what could I do at this point?
Is it alternating between the hard to- None of that. But that's all. But that's all. Oh, so that's a multiplication. So. That's multiplication. Is it the negative inside of it or on the outside? You know, I don't know. And then you're adding inside of the.
Mr. Jones.
Yeah.
You give us the practice test this week since our test is next Tuesday.
Yeah, I'm giving you guys the practice test after class tomorrow. And I'm gonna go over it, or at least as much as we can get done on Thursday. So if you try to, after you get that, I'll put it on Canvas tomorrow after class. Try to get as much done as you can by Thursday. And that way you can see what you understand, what you don't. I will really want in the future chapters, I want to, when I check, if I check the YouTube videos for the day, I'm hoping I see you guys have watched the damn videos. If you're not watching the videos, this class is going to be really, really fucking hard. Because I'm assuming you have when I give these lectures, or these little presentations. That's the contract.
That makes sense. You asked him, if he is all he's whacked, he's right down right there, it's opposite way.
It's an opposite way.
Yeah. Terminal point minus the initial point, right?
It's good. It's good.
It's terminal point minus the initial point.
Yeah.
If you are,
Oh, yeah, I'm writing it all funny. This should have been Q naught and R naught, and these are all P. Is that what you're talking about, Eric? PQ and R.
Oh, that they were backwards.
Yeah. The P naught is going to be the actual P or the point we use. Let's call this, I don't know, QR. Let's go M. Fuck it. I wrote those bad.
Oh, I see. Oh, that makes sense. Yeah.
I wrote the wrong notation
That
there. I think that's what Eric's talking about. My starting point should be P, Q, and R, which means these are all written wrong.
Yeah.
I'll call this the X vector. How about that? X is X, Y, Z. These are correct, though. I just had the wrong notation for the left.
Right.
All right, so what do we get? We got -202 dotted with X minus 1, Y minus 2, Z minus 3. -2 times X minus 1 plus 2 times Z minus 3 equals 0. -2X plus 2 plus 2Z minus 6 equals 0. I'm getting -2X plus 2Z minus 4 equals 0. I should get that if I do the other points. I chose to use P for that one, but you should get the same thing if you do it with the other points.
I think for some reason, so big.
Yeah.
To make it easier.
Oh, this is not right. Sorry. Easier. Yeah. That's the. Without over. You
I got
can
this.
logical syncing public.
ER.
The way you can. I was thinking that, you know, as well as like in your face, like now I'm finding now. Well, I got English prompters.
I mean, they're the full sound.
For which part? You said, was there some points wrong?
I don't know, I think I wrote down the points wrong. 'Cause I'm
Oh,
like-
you were-
I'm doing like huge
Let me see.
numbers. I mean, not huge really, but they're like in. Are these the points right?
What were the points for Q, Q, and R? Oh, thank you.
Oh, Eric's got it. Okay.
P is 1, 2, 3. Q is 3, -2, 5, and R is 2.1. Yeah.
Yeah. I didn't give you. That's 5 times 3, but that's 15. That's not.
Oh, I see what you did.
That should be
When
right.
you try to use vectors, you're not multiplying here, so in the second one from the first. So you're taking Q, which would be 3 - 1.
Sure.
Yeah, so you're not multiplying the, check it out. It's the second one, but minus the first. This month that. So you don't get the opposite problem.
I think this is a pretty important concept in this class. I think it's a very important concept that I make sure you know this for this class.
Oh, being able to find vectors between 2 points.
Being able to find the equation of the plane given 3 points. Because it
Yeah.
covers a lot of stuff. It covers cross product, it covers dot product, it covers planes. This very question right here covers a lot of material. And in all reality, I wouldn't do half of this work. Well, I wouldn't do half this work on a test. I would only do 1 point. I wouldn't do all 3 points. I just did this to show you guys that it doesn't matter which point you pick. So you can expect something like this on an exam. And I got one more thing I want to go over. We're going to use this very same.
I'll factor out. Yeah, you could.
You could.
Here, someone's
simplify it.
asking if you can factor out the 2, which you
You
can.
know
right?
you can. I would, in fact,
Yeah.
I prefer having X being positive. I would probably factor out a -2. I would say X minus Z plus 2 times -2 equals 0. And then we're just X minus Z plus 2 equals 0.
So
By dividing by
actually, I have a question. So I remember when it comes to equations of plane, I remember learning it with the constant always on the 0 side, on the opposite side of the regular.
We can put it on the other
Yeah.
side.
It doesn't matter much, but it's just something that I always remember it that way.
That's some algebraic manipulation. That's a way to remember it. It's useful to remember it that way. You'll also see when you're doing like the distance between planes and stuff, having it in this format's more useful.
Yeah,
But-
yeah.
So we got X minus Z plus 2 equals 0. That's the plane in a cleaner form. Then by factoring it out, that's a good point. Is there any questions on what we did here? We
Professor
started with the
Jones.
yeah.
Can you explain how'd you got the negative 2x plus 2z minus 4 again?
Yes, I took n and dotted it with these vectors. These vectors are made with doing x minus, y minus, and z minus the coordinates of one of the points in the plane.
Oh, I see.
So x minus 1, y minus 2, z minus 3 is there. On the Q1, I had x minus 3, y minus negative 2 was y plus 2, z minus 5. And then for the bottom one, I had x minus 2, y minus 1, z minus 4. You only need to do it with one of those points. I did all three to show that it works, no matter which point you use. But pick one of those points, make this little p not p vector, dot it with n because they're orthogonal.
Okay, I see.
Just like in the last picture or last problem, we had this going on. This is the same thing here. Here we made two vectors, PQ, PR, so that we would find n. And now we can take that n and use any of these points with a random x, y, and z vector in the plane.
Okay, thank you.
Okay? Uh-huh.
Yes.
Any questions on this side?
So I got a fun question for you. Let's use that last
I did
plane.
that
I'll
one
write it.
again.
I'll write the value again here. The last plane, I didn't know what it was going to be yet, so I didn't write it in yet. X minus z plus 2 equals 0. How can I find the minimum distance between a point and that plane?
Oh, geez, I remember problems like this. Shoot.
So let's discuss, reason out what's going on. The shortest distance should make a straight line to it, right?
Yes.
What will this straight line be like? What is this straight line?
It's normal to the plane,
It's the normal vector, right?
right?
Do we have the normal vector already?
Yeah.
From last question, yes.
Yes. But it may not be exactly n away. It might be further away. So we don't know. It's like a scalar multiple of n away. We don't know exactly where it is. It could be up here. It could be down here. It's not necessarily exactly n units away. So we can treat this as a line intersecting that plane. We're going to make the line the point plus t times v, and v here is our normal vector. Oh my God, Bixby, burn in hell.
That's the, I guess it's
Yes, it is. And it turns on at the weirdest times. Trust me, I know.
I figured out how to turn it off yesterday. It's not supposed to turn on when I have the phone powered or the screen lock on. The screen lock is on. She just randomly decided to interrupt me. It was supposed to not speak right now. So I might have to just permanently disable that bitch.
I think the first thing I did when I got my S20, I just disabled Bixby. This is stupid.
It is pretty stupid.
So without knowing n from the previous problem, if I wasn't given n, how do I get n from looking at this problem? If I'm just given this point in this plane, how can I get n?
One, no, 1, 0.
So we have someone saying that they know what the vector is. And how did you find that vector?
Oh, No, I'm using the wrong one. Shit. Connected to 0. Make sure that's the vector we used before.
Let's look back at what happened when we did P naught P times N, dotted with N. Let's do the bottom one where it's the easiest one to read. Here's my N, here's my P naught P. What happened with the negative 202? Where does it end up?
And then the coefficient.
Here's my plane that I came up with. Here's the negative 202. Where do the components of the normal vector appear in this equation?
No, you're right. So when I'm saying they end up as the coefficients.
Yeah, sorry, I didn't hear it. Yeah, it's the coefficients. So I don't see coefficients. They must be 1, and the y component's absent, so it must be 0, and z is negative, so that must be -1. So this line is, if I want to find this distance, I found the line here. If I want to find the distance from this point right here to this point right here, what do I need?
No, you already have a vector. What can you use?
How would
to
I,
find
what's
a
the distance formula? What's the distance formula?
Find the norm of it, or this formula is square root x squared plus y squared plus x squared.
x squared plus y squared plus z squared is what I'm hearing.
No, but he also got like the
Yeah, but we also have it's the change in x and change in y and change in z squared. So I have a point up here. I have this point. I actually need a point in the plane. I need that point where it's intersecting. What information do I have about where this line is intersecting this plane?
Point P.
Let's call let's call this P right here, up here. Let's call this Q right here in the plane. What do I know about point Q? It should meet the criteria for both the plane and the line, right? Does that make sense? Is that reasonable? The point Q is on the line and it's in the plane, so both of these should be applicable. So maybe we need to rewrite this line as something that's a little more useful. Let's turn it into the parametric equations. X equals -1 plus t. Y equals 1. Z equals t2 minus t. I have those three parametric equations from the line, and I have x minus z equals 2. I'm sorry, x minus z plus 2 equals 0. Well, it looks like I can get everything down to just time if I make some substitutions. So let's plug in x there and z there. I don't need the y component. That doesn't come into play. And now I could solve for time, right? Does that make sense so far?
Mr. Jones,
Yeah,
Got a question?
so now that you have T, so now you could plug in 1/2 for T, and then at that point, then you would do the distance formula?
yeah, if we plug in T equals 1/2, we'll find Q. And then we can find the distance from P to Q.
Can you do the same thing for R, or does that only apply for Q?
There is no R in this problem. It only applies to Q. Because I'm trying to do the shortest distance from this P. And R is going to probably be, this is not, I shouldn't have used Q. This is not the same Q as in the previous problem. That's my bad. Let's
Oh,
call this
okay.
point, let's call this W. My bad. We'll call that point W. Put point W over here. You're right. I'm like, why are you talking about R? And it makes sense. I used Q before. That's my bad. I fucked up. So we'll call that point W. Let's find the coordinates for point W. We know L is pointing to it. So W should be at -1, 1, 2 plus 1/2, 1, 0, 1.
Negative in Z. Second.
Oh, you're right. Right there. -1 plus 1/2 is -1/2. Then I got 1 plus 0, or 1 plus 1/2, 0 is 1 still. And then 2 minus 1/2 is 3/2. Well, that's unfortunate. I know I made the distance formula kind of ugly, didn't I? But that's okay. You guys know how to do a little bit of ugliness. So my 2 points are that point and -1, 1, and 2.
What were the X minus Z plus 2? I don't know how you got to that.
X minus Z. Oh, X minus Z plus 2. That was the plane used from the last one. We're using the same plane, but not the same P, Q, and R. So that plane was from the last problem. That's why.
I was wondering what I
Shit, I shouldn't have called that P, should I have? I should call that, let's see. U? Let's call this point U. Because P and Q were in the last problem.
Are
Call that-
you sure?
Oh, did he factor out the view? That's plain. You just divided.
Are you guys good so far? What, like what? I think I confused people saying P and Q when we had P and Q labeled before.
Yeah, the only
Those are
thing that's coming
common-
from the last problem is the plane that we got.
Yeah, the only thing
Nothing-
from the last problem is the
yeah.
plane. The reason why I said P and Q is we often choose P, Q, and R as generic labels for points. Maybe I should have said, we also choose A, B, and C. Maybe I should have used A, and B here. That is my fault. I should have changed the letters. But I've
So
got 2
just-
points.
Just clarifying, P naught is the only thing that we're using. That's the plane from the previous
We're-
problem.
Yeah, the only thing we're using from the previous problem is this equation. The
Okay,
equation of the plane.
thank you.
All right. So we've got these points. It's now just distance formula time. I've got -1/2 minus 1 squared plus 1 minus 1 squared plus, really doesn't matter which one I put first, but to be consistent, 3/2 minus 2 squared, square root. -1/2 minus -1, that should say. So this is 1/2 squared plus 0 squared plus negative 1/2 squared.
So this 1/√2. Yeah.
How this look?
Why is it that that's a thing that they like to have the square root on top?
There's like, that's a couple of different things. Make sure they're parallel. And then-
I don't know, but they've pushed it for since I was a child.
Just do that, show that there's.
Yeah.
Third is what? And then like. And then
Well,
from there,
it's-
I kind of just follow this.
It's kind of, it's like an etiquette thing in math where you should have if you have a square root, you should have it on top. There is a reason, and there's, but I don't really know.
It makes something easier.
Yeah, something.
See, to me, in my head, it would make more sense to have the radical on the bottom so that you don't confuse it as the radical covering the whole fraction. I think it's just a very bad design by mathematicians really long in the past. But that's just me.
Mr. Jones?
Yeah.
I'm having trouble understanding something about this problem. I understood everything up until the very end. So when you plug in the 1/2 into t,
Minus the projection.
how come you the vector that you get from that? How come you're incorporating the w and then you're doing the distance formula with w again? How come you wouldn't?
What?
That's right.
So
Yeah, okay.
this L is a vector from the origin to a point in the plane. Here's my plane over here.
Okay.
L is this line right here. It's pointing to W right there. That's L. Well, no, that's how the vector, that's how, it's really, the P naught is where is it? -1 over and the X is left. It's another point, but it's really doing.
Yeah, because that's kind of misleading because it's saying that it's coming from the origin. You really want to say that it's coming from like a point on the.
Well,
Just
no,
staying there.
L is very much this.
Oh, okay.
L is very much this. But the P
Oh.
naught's over here and N is coming in like that.
Oh,
But this
okay.
is like the laser pointer with the cat thing.
Yeah.
So that's why when I'm plugging it in, the T, I'm actually getting the point W because it's from the origin. It's actually
Oh.
giving, it's a laser pointer to where that point is.
Okay, yeah, that actually makes a lot more sense. Yeah, thank you for explaining that. Yeah, I think I just was having, I think I was having trouble visualizing actually like what we were finding. And I didn't realize that the vector, or the line was actually arriving to the end of point W. I could just picture that.
Okay, cool,
Yeah.
Sebastian.
Yeah, thank you.
All right, I think it's close to 9 o'clock. We should wrap up. We'll do more on 11.6 tomorrow. Please watch the videos.
That's really challenging.
Like you all should do really, really well in this class. If you watch the videos before coming to class, you'll have less questions.
Yeah, no. Most of my questions were just about like the plot.
All right, thank you. See you tomorrow.
Okay, see you tomorrow.
Yeah.
I feel like if you understand it, you can just skip right past everything.
Doesn't really mean no. That proved one thing. Very important.
Like, you guys, if you want, you can verify W is in this plane. Plug in W into this plane equation up here. W was -1/2, 1, and 3/2. If you plug it in here, you're gonna see that it meets this equation's formula.
I think Tuesday is Mason. That's what it is, yeah. What? Mr. Jones, real quick, can you show the top, like the original part of the equation where it gives us the points? That like pretty much the question.
The previous question?
No, just that one, the last one that we just did right now.
Let's see. I don't know which point you're wanting right here.
No.
Yeah, look, Joshua, look. So this is point W right here. Look.
Okay.
Right now, when he puts it, so this is point W.
That's point.
And then this is defining the line, right? From here to there. Right, Brandon? This right here is defining the line between from here to here.
This line.
Yeah, that's what you get. This is what you're getting. Yeah, because look, you define L as P naught plus T and then the vector.
L is very much a pointer to the destination of P naught plus T in the vector. So like if this, let me do it in another picture, where I can make it a little bit bigger. We've got P naught. We've got a vector V. Let's say that's V. And we do a couple this ends up being TV. This hits some point right here. L is this line right here. It's a vector from the origin pointing to the point on the line at that time T. It also, when T equals 0, L points right there. So L is a pointer from the origin 2 points on that line. Where it comes into play on this problem is we want L to point to the point on that line that is in that plane. And that would be this L right here.
Okay, so what is that?
So this is L. All of these are L at different times T.
Okay.
It's very much like the laser pointer with the cat.
So this is just kind of just like an extra understanding problem. Would that mean that the line LT, the angle that it makes from the x-axis would be the equivalent of the angle made by LT and point W? Would those two angles be the same? It's just kind of like an understanding question.
Are you meaning like, does this angle match this angle?
Yes.
No, that's because I could have put, I just drew it this way. P naught could have been up here. Like that.
Oh, okay.
So yeah,
And the way it
vector's
looks,
not parallel.
it looks like that, but that's not true. That's not true in general. I think my picture was misleading in that regard.
Okay. All right. Thank you, Mr. Jones.
Yeah. See
I gotta go.
ya.